Welcome to Ask and Learn.
We start by drawing the free body diagram as seen in the figure. Next step is to use the equation which state that for a static problem applied to this case, it is true that sigma f is equal to 0. Or you can write sigma mo is equal to sigma r cross f is equal to 0. Now let's stop here for a moment and think. The force equilibrium equation will provide three equations that will have five unknowns. Three forces at C, tensions at DE and AD. The momentum equilibrium, however, taken around C removes it. So we can use that to find the tensions DE and AD. So let's write all distances from C of the 3 points. The distance from C to C is 0, at which forces are applied since we will need them when writing the momentum. So in that case, I can write RBC is equal to 0I plus 0J 1.2K. RDC is equal to minus 0.8I plus 0.6J plus 0K. And REC is equal to 0.8I plus 1.2J plus 0K. Now we have to do one more thing before moving on. Before I said the tension at AD and ED has only one unknown even though it is a three-dimensional force. The reason for this is because we know that the tensions AD and AE will be in the direction of the vectors AD and AE, since that's the way cables behave. If we find the unit vector in these directions, we can write FAD is equal to FAD into UAD and FAE is equal to FAE into UAE, where the unit vectors UAD and UAE can be found as UAD is equal to AD upon mod AD and UAE is equal to AE upon mod AE. The vectors AD and AE can be found from the free body diagram, and it is AD is equal to minus 0.8I plus zero point 0.6J minus 2.4K, and AE is equal to zero point 0.8I plus 1.2J minus 2.4K. Moving further, and the length or the magnitude, we can say that for both these can be found as AD is equal to square root of zero point 0.8 square plus zero point 0.6 square plus minus 2.4 square gives the answer 2.6 meter, and similarly AE is equal to 2.8 meter. So this becomes, now I can write FAD into UAD, which is equivalent to minus zero point 0.8 upon 2.6i plus zero point 0.6 upon 2.6j minus 2.4 upon 2.6k times FAD, and FAE into UAE will be equivalent to zero point 0.8 upon 2.8i plus 1.2 upon 2.8j minus 2.4 upon 2.8k times FAD, sorry, FAE. Now we can move on to the momentum equilibrium equation around C, which gives sigma MC is equal to sigma R cross F is equal to 0. Now we have R as well as F. The R components are RCC, RDC, REC, and RCB. And the F components are C, FAD, FAE, and B. By taking the cross product of this R and F respectively, we will get the equation RDC cross FAD plus REC cross FAE plus RCB cross RCB cross B is equal to 0. Now we find each of these products. I am using the long way, or you can use the right hand rule also to solve these terms. So first of all, let's find the first term, which is RDC cross FAD. So this is the first term. Then we will solve the second, and then we will solve the third. So the solution of the first can be get as by using the determinant method. So first of all, we will have the unit vector components that are I, j, k. Then the R component. So it's a 0.8, zero point 0.6 and 0. Minus 0.8, 0.6 and 0. And then we will have FAD components, which are minus zero point 0.8 divided by 2.6 FAD, then zero point 0.6 upon 2.6 FAD, and the Z component will be minus 2.4 upon 2.8 FAD. And the solution of this determinant will give the answer minus 0.6 into 2.4 upon 2.6 FADI minus zero point 0.8 into 2.4 upon 2.6 FADJ plus 0k. The same way, the solution of the second term that I am writing directly now. So REC cross FAE will be equivalent to minus 1.2, 2.4 upon 2.8 FAEI plus zero point 0.8 into 2.4 upon 2.8 f aej plus 0k, and the cross product of the last term, that is rbc cross b, will give the answer 1.2 into 3.6i minus 0j minus plus 0 plus 0k. So now if we add all the terms in the direction I, we find the following equation. So what we are going to do, we are going to add all the items. So first of all, let's identify the items over here. So the first is minus 0.6, 2.4, 2 point, upon 2.6 FADI. So this is my item. Then in this equation, item is minus 1.2, 2.4. This one is the item. And in this is the item. So in the next step, we are going to add all these three items, which gives the answer 1 upon 2.6 FAD plus 2 upon 2.8 FAE is equal to 3. In the same manner, we can add j as well as k. So now if we add all the terms in the direction j, we find the following equation. So for the j term, we can write 1 upon 2.6 FAD is equal to 1 upon 2.8 FAE. Using this in the above equation, this one to the above equation, we will get FAE is equal to 2.8 kilonewton. And from here, I can write 1 upon 2.6 FAD is equal to 1 upon 2.8 into 2.8. So FAD will be equivalent to 2.6 kilonewton. Now all that remains at this point is to find the reactions at C. This we can do using the force equilibrium equation, which leaves sigma F is equal to C plus B plus FAE plus FAD is equal to 0. As C is CXI plus CYJ plus CZK, B is minus zero point 0.8 upon 2xi plus zero point 0.6 upon 2.6j minus 2.4 upon 2.6k times 2.6. FAE is equal to zero point 0.8 upon 2.8i plus 1.2 upon 2.8j minus 2.4 upon 2.8k times 2.8. And lastly, FAD is equal to 0i minus 3.6j plus 0k is equal to 0. So by putting all this over here, the final solution we will get, which will be equivalent to Cxi plus Cy minus 1.8j plus Cz minus 4.8k is equal to 0. The three equations we get from the above equations are Cx is equal to 0, Cy is equal to 1.8 kilonewton, and Cz is equal to 4.8 kilonewton. So the reactions at C will be equivalent to C is equal to 1.8 J plus 4.8 K kilonewton. And that concludes our answer.